further ado, let's begin. So over the course of my last 8 years as an engineer, I've heard some recurring themes, and even in my own story, about learning JavaScript. One of the first ones is JavaScript is hard. And especially for me in the beginning, as with most things, if you're unfamiliar with something, that's really where a lot of this fear or percepting something is hard comes from. So when you're new to coding, or if you're even a seasoned developer and you've just been avoiding JavaScript your entire career. So that's kind of one of the reasons I've heard that JavaScript is hard. Another thing I've heard is JavaScript is complicated. And in the current ecosystem, you can see why. Fred mentioned it earlier, where we have all these things with bundling and how it's grown. The evolution of it has gone through so fast in the last 10 years that they kind of just built on top of features. Some were working, some were not working. If you used JavaScript before ES 2015, oh my, you probably know about those issues. And one of the biggest things, for me at least, was the fact that it's paradigm agnostic, meaning there's different styles that you can use JavaScript in. So me coming from a C# background, how I learned to program was in an object-oriented programming style. And as I first started learning JavaScript, I did it more in a procedural fashion, which means I wrote every line telling the computer exactly what to do step by step, and it's not always the most efficient way to do that. Now I'm striving to move towards more of a functional programming style, which we'll get to in a second. So believe me when I say I understand JavaScript is confusing. Most of the time, I pretty much felt like this. Yeah. So, what do? And with most problems in my life, I tend to throw lots and lots of sugar at it, and in the form of desserts. So that's what I want to do today, is I want to talk to you all about filter, map, and reduce, and the way that I have tried to learn these particular methods. And we'll start with the one that I've personally found the easiest to understand, which is filter. So filter, you can kind of gauge what it means by the name itself. And when we look at the actual definition from the Mozilla docs, we get this very verbose, very academic definition, which is the filter method creates a new array with all elements that pass the test implemented by the provided function. Cool. I think there's a tastier way to explain that, and that's what I did. So let's say we have some food here. I put some food in my food array. I have a donut, a couple cookies, a random carrot, and a croissant. And let's say I wanted to only get cookies because cookies are life and cookies are awesome. And we can do that. We can do that with the filter method. So we'll do that. We need to do something with our food array, so we'll get that. And we'll use the filter method. But JavaScript's not that smart, right? I wish we could just do that and it should automatically take the cookies out for me, but it won't. We need to give it some sort of expression. We need to give it something that returns true or false so that it knows what to filter. So we can do that, and I'm using the fat arrow syntax here. So pretty much for every item in my food array, I'm going to say, hey, is this truly a cookie? Oh, it is? Okay, cool. You get to go in the only cookies array, which is the new array. And when you console log that, that's the output, and you get 2 cookies. Pretty easy, and at least that's very easy for me to understand, especially when there's sugar involved. So in order of increasing difficulty for myself, map was the next one. And you usually like to use map and filter together. So again, official docs, the map method creates a new array with the results of calling a provided function on every element in the calling array. And I'm like reading this to myself. I'm saying, tell me again, only tastier. So that's what I did. So let's say I have a bag of marshmallows. And I decided to model that in the way marshmallows come, with its squishy form. Some are a little more squished than others. And I decided to model that in my array with different casing here in marshmallows. And then I was thinking to myself, what if I had some sort of machine that could jumbo size these marshmallows, because the only thing better than marshmallows are jumbo perfect marshmallows. So that's what I thought of. And these are the kinds I think of when I'm waiting for npm install to finish. So, so again, we take our bag of marshmallows. We have our starting array that we're working with, and we're going to use map. But just like filter, we need to give it some sort of expression or function to work each item in my bag of marshmallows. And in this case, map does something to every element. So in this case, the thing that I want to do is to jumbo size it. So to do that, we'll take every marshmallow. And since these marshmallows are string marshmallows, I'm just going to uppercase it because that will give me my jumbo marshmallows. Cool. Sweet. Jumbo marshmallows are awesome. But I'm sure you guys are wondering, and ladies, what's that random cloud doing there? So the cool thing about these kinds of functions, and what I mentioned, functional programming, is that you can chain these methods. And for one of the things that I pointed out here, one of the things we've noticed is I want to filter out that random cloud. I don't want to make a cloud a jumbo marshmallow. I just want to make marshmallows jumbo marshmallows. So let's do that. So we have the map function that I've used. We're going to take that and we're going to move it down a little bit because we're going to use it in a bit. And while we're at it, I'm going to take my jumbo marshmallows variable and I'm going to change that because I want to be a little bit more explicit. So these are not just jumbo, but they are also filtered jumbo marshmallows. So now, what do I have to do? I need to filter out any random clouds first. So we'll do that, and we'll do that with what we've used, filter. So we'll filter. And there are many ways to write this. Again, this has to resolve true or false. So for brevity and to make sure it fits on my slide, I just chose to make sure that it is in fact not a cloud. So we'll do that. We filter out all the clouds. And the cool part about this is that, remember, filter creates a new array. It doesn't modify our old bag of marshmallows, which is helpful because if we ever needed to reference it again, that won't be touched. That will still have all the weird casing. That will still have that cloud in there. Filter, the resulting array that comes from that, will only be the marshmallows. And then because these are chainable methods, now map is working only on the filtered marshmallows, none of the clouds. So that's exactly what it does. It will go through, it will map only those things that have been filtered out, and we get our full jumbo marshmallows. Awesome. So next one, reduce. This one was the most challenging for me to understand. There was a lot of big words and extra parameters and just made me go crazy. So again, official docs didn't make it any better. The reduce method executes a reducer function that you provide on each element of the array, resulting in a single output value. Yeah, that's a mouthful, and that's not the sweet kind either. So again, I'm going to throw another one of my dessert examples on here. And for me to learn these things, I need examples that keep me engaged. And what keeps me engaged is sugar. So for all the sweets that I eat, randomly I decide to keep a donut log. And these are all the donuts I've eaten over the past week because I need to keep track of this and know ultimately how many calories I've consumed over the week. And that's exactly what we're going to do here. So calories consumed. So we can use reduce to calculate how many calories of pure donut I have eaten over the week. And again, we are going to give reduce that reducer function that I was talking about. So you'll see here, oh gosh, extra parameter, what do we do? And that's exactly what kind of came across my mind. But it's not that scary. If you cover the accumulator variable, you'll see it's very similar to map and filter in that we're passing that current value, the thing that we're going to iterate on every single time. The specialty with reduce is that it has this accumulator variable, meaning this is what I like to call built-in storage into this function. So not only do you get to iterate on something, you get to keep track of something, and that's what reduce is usually used for the most. So in this example, I want to switch that variable name because it just confuses me. So I'm going to switch it to last count because in this case, the thing I'm keeping track of are the calories consumed. And the last thing I'm keeping track of is the last calories that I've counted. And at this point, the other special thing about reduce is that you can set that initial value. So this last count, when I return it, will be 0, which you've seen here, because assuming I've been good and I haven't eaten any donuts, it would be 0 at this point. So as we iterate now, what we want to return from this is the total number of calories that I've eaten in donuts per day. So we do that by returning the last count, which at the very start, this would be 0. And we're going to add to that the current entry that I'm on, so the number of donuts that I've eaten. And we're going to multiply that by some Googled figure of the average amount of calories in a donut, 278. And as we do this, we take, so, for Monday, it would be, I ate 2 donuts, you multiply that, that's 556 calories. We're going to add that to, at the start, 0. And then what happens with reduce is that result, that 556, that's now the new last count. So the next time you go back in and you pass that in, your next entry that you're working on will be Tuesday. And then you'll add another 278 to the previous 556 calories. And that's kind of how reduce works. So total output is 3,336 calories. That was a great week. So with all of these methods, I wanted to show you how cool that could be to kind of chain all of those together. And I recently looked up what the best donut shop is in Omaha. And I'm sorry if I offend anyone if you have like a place, but Google says it's something called Olson's Bake Shop. Is that true? Yes? I got one person, so Google's really one person. All right, cool. So I took a look at their menu, I took a look at their offerings, and I decided to add that into a menu here. So I have a chocolate donut, I put the emoji there. I have the calories, which I kind of guesstimated. And then from the recent pictures that I could kind of zoom in on, I got the price. This might be a little outdated, but so these are some of the offerings that I did find. A chocolate donut, chocolate chip cookie. What is this? Oh, so they actually sold bread, sliced bread, some croissants, and they did have some cookies. So I saw one that was a yellow iced heart cookie. So I added that into my menu here. Now, I was wondering, how do I use these, methods, and how do I use them in a way that I can show the different chains, or at least use all 3 of those methods in one? And I thought, well, it'd be cool if, let's say, I could place an order of just the emojis, and from that, I could calculate a receipt of what I had ordered, the number I ordered, maybe even show the emoji of what I ordered, the price, the typical receipt that you would get. So we'll store that in my order here. And because I have no shame, I ordered 3 chocolate donuts and 1 heart cookie. The 3 donuts are for me, 1 is for my husband. And I looked up sales tax. Again, Google, please correct me if I'm wrong. According to Google, Omaha sales tax is 7%. So we'll keep those there. And now, the first thing I want to do is get my receipt items ready. So to start, I will store this in a variable. And from the menu that I've created, I want to first filter out only the things that are in my order. So what I'm doing here is, as I'm going through the menu items, I'm basically checking, hey, does my order include this specific food emoji? If it does, that's something that I want. That's something I want to keep track of. So keep that there. Now, after I've found the information about all of these things, I want to map that because I need to calculate some prices. So for each item, I want to get the number ordered. And what I'm doing here is I'm filtering the emoji that I have, meaning what the order is. And by filtering it when I'm filtering it, the remaining amount is how many I've ordered. So that's the length. So it's the number ordered of that particular thing that I've ordered. And after I get that, I want to return the emoji because I want to print that on my receipt. I want to print the price of that times the number that I've ordered and give back the number that I've actually ordered. So that's all stored in receipt items right now. That's all ready to use, and that will be useful later on when you go print this. So the next thing I want to do is calculate my totals. So that's the tax that I was talking about, the subtotal, all the things that you see at the bottom of the receipt. So let's do that. We have a total. And what I'm going to do here now is I'm going to coolly keep track of two things. So in reduce, when I showed you my earlier function, I started with an initial value of 0 calories. But the cool thing is it doesn't have to be just an integer. It can be anything. And in this case, I'm using an object to keep track of, because I'm not only keeping track of one thing, I'm keeping track of my subtotal and my sales tax. So as I go through in here, you'll see here it's a little different. I'm using some destructuring here when you see the curly braces and price, because that's the only thing I care about for this particular calculation. So I declare my subtotal, I declare my sales tax, and as before, totals.subtotal and totals.sales tax, those two are my initial starting point, which again, at this point will be 0. And after we go through every price of the things that I've ordered, I want to add that price to the subtotal and sales tax, I'm sorry. And in the sales tax, you'll see I'm calculating the price times the Omaha sales tax constant that I have. So with all of those calculations, I return the final subtotal, the final sales tax. And as before, this initial value, that's where it's at. The subtotal starts at 0, sales tax starts at 0. So as I run through my reduce function, it will keep adding to those and return those for me to use in a moment. And forgive me for this. This is just to show you, you would not want to do this in real life. You maybe want to use a template or something. But this is just to show that you can use this. You don't need fancy third-party libraries or all this stuff. You can do this with vanilla JavaScript. And here I'm ultimately going to print out my receipt. So you'll see here, for what I'm using here is map. And I'm using map to pretty much go through my items and print them out in the particular place that I want them to. And we're going to console log that. So taking a bit of a risk here and going to print this out. Oh, of course it's not here. Did I close it? Still got 2 minutes. Don't worry. I'm going to make it. All right. So cool. Okay. Let me just copy this because I'm afraid everything else is not going to work. I want to make sure you see the same thing that I actually placed in my demo. Then let's do the heart cookie. So, okay, so I ordered 3 donuts and 1 heart cookie, right? And I wanted to show big hurrah, I actually run it in here because I wasn't able to get the integrated terminal into my presentation, but cool. There we go. Yay. Oh, man. Thank you for your patience. Let me get back to the final slide that I have here. Okay, so I console logged that receipt, that darn receipt, and you guys saw that. And yeah, thank you. Salamat. Salamat means thank you. And Tagalog, thank you for bearing with me. Thank you for looking at this. And I will make sure to take more calculated risks next time. Yeah.